Hey, welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. If you're new to the channel, please subscribe and click the notification bell icon. This is a news update episode. Let's look at some AWS top news headlines. Okay, the first news is coming from AWS XRay. XRay now supports VPC endpoints. What is XRay? XRay basically a tool that allows you to collect information about how your request is actually flowing between various kind of processes in a distributed architecture that is essential to understand how your calls are being made. And an example of it will be like if you have multiple lambdas calling each other, how do you know how much time each lambda has spent in each of the process that it is running? So X-ray gives you that insight. Now you can use an X-ray using an SDK in this picture that is pulled from the AWS website. So you can have an SDK of X-ray that talks to a daemon and which internally invokes your X-ray APIs that collects all the data. You can also implement AWS SDK as another client or the CLI that can talk to the X-ray API, or they can go through the daemon again and have the same data pushed to the X-ray service. Now the X-ray service use that data and brings you a chart like this, which is like multiple circles showing each process, how the request is flowing between the processes, and you can see how much time each process is taking. So basically you can look at what exactly is taking most of your time in processing a certain path, or maybe end-to-end process. You can have a detailed evaluation. It's very much like App Dynamics, where it can provide you information on each function and lower level changes that are happening. So in this case, it is more about each process taking how much time in a distributed environment. Now, X-Ray announced general availability of a VPC endpoint support, which makes it possible for you to establish a private connection between your VPC and the X-Ray as a service. X-Ray is a managed service through AWS. You don't have to do anything. You don't scale it. It is all done for you. X-Ray is very helpful to look for a trace on your application. So application running in your VPC can communicate to X-Ray, and this data that you have to send to X-Ray in order to draw the picture that you can see on the X-ray console. This data was earlier flowing through public internet, but now because it is supporting a VPC endpoint, this data will stay on the AWS network and it is not going through public channel, which is a good thing. With the private link, you can create an interface VPC endpoints to access X-ray API through your VPC. VPC endpoints deliver reliable connectivity basically to your X-ray without requiring any internet gateway or network address translation devices or net devices, or you don't need a firewall proxies. Now, if you think about the real building block over here, AWS VPC is basically the building block, and every service that you have, when you launch your resources in AWS, you basically launch a VPC where you define it's a virtual network where you define what kind of network settings you want, what kind of IP ranges you want, how many subnets you want, what kind of route table, network gateways, etc. Anything that you think of you in any resource that you want in that VPC. You define all those things, and then in order to connect to a VPC, in order to connect your VPC to the X-ray, you define an interface VPC endpoint. Now, using that, the VPC endpoint actually relies and provides a scalable connectivity to X-ray without going through, as I already mentioned, internet gateway, NAT, or VPN connection. So it's a pretty good development at the Amazon side, providing a VPC endpoint that can run your data in a more secure way, powered by AWS Private Link. Moving on to the next The next news headline is from A2C. Now, A2C is basically application App2Container. A2C now supports containerized app development to app runner. So I have put a picture. What is A2C? Basically, AWS App2Container or A2C is a command line tool interface for modernizing .NET and Java application into a containerized application. Now, A2C analyzes and builds an inventory of all the applications running in a virtual machine in an on-prem or in the cloud environment. And after analyzing and discovering, they can extract and containerize. So basically, this is the first step where they analyze and then they can containerize it. And then this can be actually deployed like a artifact in your ECR or ECS, basically as a container repository. You can put it in a container repository and then deploy using a Fargate cluster or a Kubernetes cluster. So that is what A2C brings to the picture. What exactly this news is, now A2C now supports deployment of containerized Java and Spring Boot application to App Runner, AWS App Runner. So with this feature, user can now target App Runner as deployment runtime in addition to ECS and EKS. So ECS and EKS is already there. So if you see this one is where you can deploy. But now you can do a deployment on App Runner. Users can take advantage of continuous deployment, auto scaling, and monitoring of deployed web services offered by App Runner. Pretty good addition as an integration point of view in anything that is already running on legacy application where you can't change the code. You might have to live with that code. Is It's a good start just to do a cloud journey or to start a cloud journey. Moving on to the next news. The next news is coming on AWS. Customers can now self opt-in to AWS Wavelength Zones. So what exactly wavelength zone is? I have put a picture for a better understanding. In the picture, you can see there is a region and there is a VPC and you have AZs. Everybody knows about AZ and subnets. What is wavelength zone? So wavelength actually enable a developer to build applications that can deliver ultra low latency mobile devices as a consumer over here. So you have a carrier gateway and then you have a wavelength zone where you can have subnet. So it is very much, doing a deployment of standard AWS compute and storage services to the edge locations. Um, and this is running on like 5G telecommunication network. So customers can now easily enable AWS wavelength zone themselves from creating a new settings in the EC2 console. There is a setting, or you can do a modify availability zone group API. You can use that. Once enabled, basically the customer can create and manage resources in the wavelength zone using the same APIs. And management console they use for AZs in AWS regions. So that can be done as usual. Default, there's no change on the AZ. You can extend an AWS VPC to one or more wavelength zones, and you can then use the AWS resources like EC2 instances to run application that require ultra low latency and a connection to AWS service in the region. So the concept of wavelength is basically what is a wavelength? It's a new type of AWS infrastructure designed to run workloads that require ultra low latency for mobile networks. What is a wavelength zone? A wavelength zone is basically a carrier location where the wavelength infrastructure is deployed. Wavelength zones are associated to a region. So a wavelength zone is a logical extension of a region and is managed by the control plane in the region. Carrier gateway is basically it is serving two purposes. It allows inbound traffic from the carrier network to a specific location and allows outbound traffic to the carrier network and internet. Moving on to the next. The next news is related to EKS. Now, EKS add-ons now support CoreDNS and cube-proxy. So if you know about EKS, it's an Elastic Kubernetes service, and it now supports to install and manage CoreDNS and cube-proxy in addition to the existing support to VPC CNI network plugin. So a picture of EKS over here, and if you look at it, you have 3 AZs, 1 VPC, and then each AZ has a public subnet over here and a private subnet, and you have a bastion host with an auto scaling group associated, and this bastion host is in all 3 AZs. Similarly, in the private subnet, you have a auto scaling group around the Kubernetes, and you have nodes, Kubernetes nodes, and then you have Amazon EKS over here. So what exactly we are getting in this particular change? Now, EKS is going to support from the console CLI and API to install CoreDNS and cube-proxy. These are the additional plugin. As of now, it was just having the CNI network plugin. This makes it easier to define consistent EKS or Kubernetes cluster to keep them all up to date using Amazon EKS. Now, CoreDNS and cube-proxy provides critical networking functionality for the Kubernetes applications. These operational software components or add-ons, they can be installed, managed, or updated directly through the console CLI or API. You can see the available add-ons or compatible version in the EKS API by selecting the version that you need to add. You can also configure some settings, key settings such as IAM role used by the add-on when it runs. Using EKS add-on, you can go from cluster creation to running application in a single command and keep your cluster up to date using the Amazon EKS console API or CLI. Amazon EKS supports managing the installation and version of CoreDNS, cube-proxy, and the Amazon VPC CNI on clusters running Kubernetes version 1.18 and above. Moving on to the next news. The next news is about EventBridge now supports sharing events between event buses. So if you look at this, we have an EventBridge service. Now, EventBridge is a serverless event bus that makes it easier to build our event-driven applications at scale and using events generated from your application, SaaS applications, and AWS services. So if you look at the picture that I have pulled from AWS documentation, on the left side you have AWS services, custom app, SaaS application, microservices, and then you have a schema. Now, all of these are putting their schema here, which goes to a schema registry, and that information is here. And you have these putting all the events, so basically getting all these events in. Then you can have different kind of buses. You can have a default bus, you can build a custom bus, or you can have even a partner event bus where it raises an event. They do a schema discovery through the registry, so they know what all schemas are available based on what all event sources are. Based on some set of rules, they send it to the target. So these can be the targets, and targets use the schema to do the binding. In this case, now AWS Lambda, you have SNS, and other targets. So on the right side, you have all the targets. On the left side, all services are there, and this is where event bus comes into the picture. They're just taking event from one source and mapping it to a given target based on the event that has been raised. EventBridge connects applications using events An event is a signal that a system state has changed somehow. EventBridge registry, the schema registry stores schema generated by your organization's application. AWS services or SaaS applications, which includes information such as title, format, validation rules for the event data. You can download code binding for any schema in the registry in your IDE and directly use a strongly typed object representation of the event in your code. You can now configure EventBridge to send and receive events. So you can have multiple event buses in the same account and region to aggregate all your events from different event buses into a single event bus. You can also fan out event in a single event bus to other event buses, making it easier to decouple your application and produce more extensible, maintainable, event-driven architecture within your organization. So something that you should be aware of if you are an architect or if you're looking for a professional certification in architecture. Moving on to the next news headline. The next news headline is about AWS Application Cost Profiler. Now, this is a new service, a new capability. So AWS announced AWS Application Cost Profiler. It's a managed service that enables you to view basically cost of AWS resources for software shared between multiple users, or you can say multiple tenants. Now, in this case, what you're doing is you enable application metering with this information like tenant metadata and what kind of ingest they are doing. And then you can do a profiling around that information. So application cost profiler collects tenant metadata and report hourly breakdown of the cost per tenant on a daily basis and monthly basis. You get a detailed report about this information in a desired frequency, and you can consume it programmatically to build your own dashboard and track like what cost pattern or margins by tenant. If you're an independent software vendor, your ISVs basically can use application cost profiler to get a granular breakdown and help understand gross margin from each tenant basically. So ISVs can use an application cost profiler to get granular cost breakdown and help understand gross margin for each tenant. Organizations who run application and that are shared between different teams can use this to define internal proportionate cost allocation model based on the usage. So suppose you are sharing a service which is at an organization level, you can use this to identify which group, which department is using what percentage of this shared service. With Application Cost Profiler, you can now access a detailed tenant level cost insight and adjust the architectural design, product pricing strategy, and cost allocation model to achieve highest adoption and profitability. This is the end of the show. Thank you for watching. If you liked the content, please like, subscribe, and press the bell icon for future updates. This is your host, Bhavesh Kumar, signing off. Thank you.